Greetings, everyone. I'm still Mr. Matonsi. We will be continuing from where we left on the last video, which I was explaining the congruence and the similarities, which it will be helping us to prove this theorem. But then the triangle with sides and proportions are similar, the similarity one. But then I want to emphasize this one, like I want to emphasize this before I take on what we need to talk about today. I want myself to just take a bit and explain this one, like something like this one, because other people, they tend to forget what I told them. Okay, so I want to say, take a note, like as if you're given, they're saying maybe prove maybe triangle AEF that is similar to triangle maybe D. Okay, this is what we're given. Basically, let me write it. It's triangle AEF similar to triangle AMD. Okay, this is what we're trying to prove. Okay, so take a note that here basically you are given the answers. Okay, you are given the answers, but then you should give the reasons. Basically, what I'm trying to imply is, what I'm trying to say here, I told you that it should be like this. If it's triangle AEF, you should also write it. You should not write AFE. This is correct. And then you say this is similar to triangle AMD. No, this is wrong. Okay, as I emphasized on the last video. But then here you're given the answers that this triangle is similar to this one. Why am I saying that? Here, the first letter corresponds to this first letter. Basically, what I'm trying to say, I'm saying this A and this A, they are equal. If you can check maybe that diagram, the diagram you're given, eventually you will just get that this A is equal to this one, and also this E is equals to M. So what you just need to do is to find the answers, the reasons, and also this one is equals to what? F is equals to D. So basically you're given the answers. You just need to find the the reasons. Okay, we will see whenever we are going, we are taking the examples when or after we are done with these theorems. Okay, because most of the time you will be asked this, and it contains a lot of marks, so you need to play around them, okay, more often. So today we'll be doing this. The theorem states that triangles with sides in proportion are similar. It means if they're having what the sides when the sides in proportion they're similar. If this side is similar, okay, this side is in the same proportion with this one, it means these triangles, and this one is same in proportion, it means that there might be what they are similar. Okay, so now it says that the statement says, if the corresponding sides of two triangles are in proportion, then the two triangles are similar. A reason, sides of triangles in proportion. So we are given ABC, and triangle DE. Basically, we are given these two. We are not given this line. We are not given this line. We are not. Okay. So take a note. So we are given triangle ABC and DEF. Okay. And then we also know that we also have what with this. Basically, this implies. This is what we are given. Basically, we just need to prove what this theorem. We need to prove. We need to prove the. Basically, we really need to prove that the angles, that angle A and angle T, they are the same, they are equal, and then angle B and then angle E, they are equal, and then also C and F, they are all equal. They are equal. Sometimes you are going to be given. Sometimes you are going to be given what? You're going to be given you're going to be given this, I mean the angle. You're going to be given that they are equal, and you will be required to prove what this. So it should be easier playing around this thing, because if you can be able to prove that this are equal, if you are able to prove that these ones are equal with using what you are given, which is this one, that meaning that it's easy for you to prove. It will be so easy for you to prove the what we call it's going to be easy for you to prove these two. So basically, sometimes you're going to be asked to prove this, sometimes you're going to be asked to prove the angles. Okay, so now let's prove. Okay, so you will write what you're given. You will write what you're given. Okay. Eventually, this is what we're given. This is what we're given. So you have to write what are given when you're proving in your exam. Okay. So first, let's construction. So we are talking basically construction. So we're saying now, let's draw a line. I told you that this line is not there basically, so you really need to construct it. So draw GH or line GH such that let me just say line so that people can see that I'm talking about a line. Draw line GH such that AG is equals to DE and AH is equals to DF. We are saying draw a line between A. We are drawing a line between A and B. Marking a line. We are marking it here. And also A and C, we are marking what? F here. So basically we are saying now you connect those two lines. When you are connecting such that this triangle will be equals to, basically not related yes, you can simply say if obvious, that will be obvious. If this line and this line are equal to this one and this one, obviously the triangle are going to be equal. Okay, they're going to be equal. So that's what I'm trying to say. We're saying we're drawing a line, we're marking a line on G such that this line is equals to this one. We are also marking a line on AH, on AC, such that DH, they are also equal to AH. Okay. Then now let's see. Let's start to prove. Now we see that since now we see that AB AB over, let me use a different one, let me use a different color so that I can a bit explain. We are seeing that AB over this one, it can also equals to this one over this one, okay, and also this one over this one, and eventually we are given here. So basically we are saying that this side over this side, this side over this side, meaning that AB over DE is equals to AC over DF. Basically we are what? We're given because it's here, we are given there. Okay, now since we have constructed a line, this line, we have constructed it, so it is clear that now and mind you, we said we are constructing these two lines such that we are joining GH such that this triangle should be equals to that one. Now then we are having AB over, this is A, basically now green, yes, now we are saying AB over AH, okay, AB over AG, sorry, not AG, or not AH, and then is equals to AC. AC is the distance from here to here, okay, sorry, okay, yeah, and then now we have over here, because this distance is from this GH, GA, and also we should also note what HA or AH, AC over AH. This is by construction, because we constructed the line. Then now, since we were able to pick up here this one and this one, we tend to remember theorem number 1, which we spoke about earlier on the other videos. We tend to see that if we are allowing this to happen in our triangle, that we can say this over this is also equals to this over this. That is what is the sides in proportion. Okay, so meaning that since we can say that, then meaning that GH, this line, if we can draw, remember we can state this only if these ones are what? Are parallel. But then we were not told that they're parallel, but then we can have it. That eventually it means if we can have this equation, it means that these two lines are what? Are parallel. Then eventually we say now GH and BC are what? Are parallel. Therefore now they are on the what? Sides in the same proportion. Remember theorem number 1, sides in proportion. Sides in proportion. Okay, so now since now we said, let me first clear this because I'm using these drawings. Okay, since now if we can check, since this line is parallel to this one, mind you should know that we said first, before I turn to I said first on this first statement, we said triangle AGH is equals to this one. You should not forget this one, that one. Okay, they're equal. But now we see that GH, we can see that GH is parallel to what? To BC. We stated that. Okay? So if these two are parallel, means we can see from our grade 10 mathematics, we can see that this triangle is equals to this one. Okay, it produces what? The F shape. That's what it says, the mathematics. It means this one is equals to this one. If we have a parallel line, it means this one, it means we call them what? The corresponding angles. Okay, it means if we can twist this diagram, we can have an F shape, meaning that this one will be equals to this one. Therefore, we are saying, therefore, angle B is equals to angle AGH. AGH is this one. Take a note of the G. The G is the one which takes a cap, meaning it's the angle. Okay. Therefore, we are saying the corresponding angles. Corresponding angles. Okay. Therefore, we state which one is it corresponding, meaning that GH is parallel to what? To PC. Same here, meaning that this one, we can produce an F shape here, an F shape. This one and this one, let me put a star. This one and that one, they are what? They are equal, meaning that also angle, therefore angle C is equals to what? A, G, H, and G. The same angle, the same reason, corresponding angles, such that GH is parallel to PC. Okay, so that's when now we can see that these triangles are equal. So basically, since we can see, now we can see that this triangle means this angle is close to this one. This one is close to this one. And mind you, let me use some different colors. So now we stated and we know that this B is equals to this G. And at the first we said these two triangles are equal, meaning this one, meaning angle E and this angle G, they're equal, and this G is equals to this one. It means they're equal. And then we also say that this angle is equals to this one, and also this one is equals to this one, since we have some corresponding angles. And we can see that one, this one is more clearly, this one is clear that this one is going to be equals to this one. They are okay, because you have three angles in a triangle. So now we can see that the bigger triangle, since we have this one is equals to this one, this one is equals to this one, this one is equals to this one, then we have three. What? We have three. Okay, but we have three angles. Mind you, on the last video we said we need three things to prove the equiangular you need three things to prove to prove two similarities of a triangle, of two triangles. Okay, then since we know, let's drop this one. We are not focusing. Let's focus on this bigger one. Since we see that, therefore we can say that triangle ABC is similar, we can see that, to triangle what? AGH. Take a look again. AGH here on this one, A is equals to A. B, this B, this triangle, this B, the angle of the angle P is equals to G. Let me use this one. We can see that A is A. You can see this one is present in both triangles. And then B, angle P is equals to G. You can see this B and this one, they're equal. And then C is equals to H. You can see that C and H, they're equal. So basically you should put them like that. So the reason, so let me go back to my black. So the reason now is what? Equiangular what angles? Equiangular triangles. So meaning that they are both what? Equiangular. They're equal. Like, yes, they're equal. Okay. So then now, since now they're equal, it's clear that I told you. Okay, let me rewrite this. It's triangle what? A, B, C, similar to triangle AGH. I told you on the previous video, I said if you say A over B, it means here you say O over G. If you say B, C, it means you say BC over GH. If you say AC, it means you say also over AH. I think I'm getting myself clear on that one. Okay, but then I was not trying to emphasize that now. But then you should know that because it's important and it can give you some hint when you're writing and yes. So basically, now we know that we're trying to prove what these triangles. So now it is clear from this we can see that let me just crash this one. Okay, yeah. Then now from this we can see that BC, I mean this BC, it means if you're taking this BC, you're going to also take what? GH over GH is equals to what? We also take what? A and B, A, B over AG. We can see that. And which is this one? This one is equals to, if we can check. And also someone could also write, because others can others will also write. It means, I'm saying, I hope you will get this clear. You can also rewrite this in this form. You can say triangle AGH is similar to triangle ABC. So basically, when you are using this one, you are going to have here, you are going to have what? GH over BC is equals to AG over AB. So can you see what happened? So I just tilt or substitute, or maybe let me just say tilt sorry, here it's BC. Okay, so you can see, so you need to play around this thing. Okay, then now if let me go take and use this one, continue with this one. You can also use this one, it's the same thing. Okay, it's the same thing. Now if I continue with this one, I will have what? GH over BC is equals to AG over AB. then we can see that this is also equals to what? DE over what? AB. Now we are involving this the second what? Triangle. Sorry, so let me, yeah. Why am I saying that? I'm saying GH over BC is equals to AG over AB, which is also equals to DE over AB. We just replaced what? A by D. We replaced G by E, as you can see here. Okay? So the reason now is what? AG is equals to DE. By what? By construction. By construction. So here, here, you are going to have what? From this point, from this one, you are going to have what? You are going to have is equals to what? Here, AB over DE. Therefore, the reason was going to be the same. Then, which is also equals to let me continue use this pen. Which is also equals to EF over BC. Now we were given that what? AB over DE is equals to BC over EF. So that's what we were given from where? This side. So if we can check it, this is what we are given. Mind you, from this point. Okay. So we can see that from this point, AB over DE. This is the same thing. Okay. So we are trying to keep. We're still what? Solving. We're still solving. Then we're still proving. Then now we have therefore GH is equals to EF. Okay, we can see from then from this we can draw that GF is equals to what? EF. It means that GF, this GF, the line GF is equals to what? This one. Okay. Then now we can have, therefore we can have it that these triangles are what? Are equal. Because now we said HE and DE, they're equal, meaning that is what? Okay, let me say. Okay, now we have what? Triangle HEH is congruent to what? DEF, meaning that we got this side, this is the side, and we also had what? This side. This side by this one is by construction, and this one it was also by construction, and we also have this one. We solved this one from this one. It means now it's side, side, side. Okay. Therefore, we can now come to conclusion that therefore triangle ABC and triangle DEF are equiangular. Sorry, sorry. Are equiangular. Therefore, triangle ABC are what? Are they are similar to what? DEF. Okay. So basically, first we spoke that we need to draw a line that we are marking what? A line. We said we are marking G on AB, and we also marked what? H on AC, which is equals to what? DE and what? DF. So after that we say AB over DE. We were given that here, and we also used by construction this the sides in proportion from theorem number 1, and we also got the corresponding angles, since we ended up concluding that GF is parallel to BC. We ended up getting two corresponding angles, and therefore we went to say we got the other proportions. We got other proportions drawing from to the results we got, and then we ended up coming that the reason it was because we wanted to check to get the last side, which is GF. It was GH, trying to equalize it to EF, and then we got it, and then we came to our conclusion that they are congruent, and the reason was side. Okay, and then now on the last we saw that this triangle ABC, the bigger one, is equiangular to DEF, and then now we just concluded that they are similar. So now I want you to go and then prove now that you are using the same diagram. You are proof. I want you to, it's the opposite of, not really the opposite, but it's similar. It's the same thing. Okay, so I want you to prove when you are given, let me write using on the next page. You are given triangle ABC and triangle DEF with angle A is equals to D, B is equals to E, and C is equals to E. Therefore, you are required to prove that AB over DE is equals to AC over DF is equals to BC over EF. So I will request you to prove this one using the same diagram. So these two proofs are also in those books, in the Siavula book, which I also sent you, and the Mind the Gap, which I also sent you. So in the Mind the Gap, it's unit 12. Let me check the page. Oh yeah, Mind the Gap. Mind the Gap. The Gap. It's page. Mind the Gap is page 241, and then also on the other one, which is Siavula, is page 341. So thank you for your time. I hope you enjoyed, and stay blessed. Practice more, because this proof might come in your exam, so you don't need to lose about 7 marks to 10. So you really need to play around with this thing. So enjoy. I will see you. Enjoy your day and enjoy your time studying. Just know that the last kick of a dying donkey is dangerous. So don't waste your 12 or 13 years in in school, especially primary, plus the years you spend in high school just for fun. So you really need to study so that you can pass and go to varsity or college, so that you may further your studies. So you really need to stay positive and stay motivated. Thank you. Don't forget to ask questions on you can ask anything, and please make sure that you ask any question. It can be financial mathematics, it can be probability, it can be the sequence and series, everything, anything, because we no longer have time and you need to write your exams so soon. So thank you for your time. Bye.